Here we are for part two. The title, I don't know, do I sound like a boomer? Can you say libs for libraries? I'm going to try to start that. This is a trend now. Okay, we're making it happen. I mostly just wanted to rhyme. So we're going to talk about libraries in Python and then vibe coding, which I just absolutely adore, both the name and the activity. All right, libraries in Python. There are really only a few that we're going to focus on in this course. There's many, many out there for lots of different purposes, but we're going to be focused on math and a little bit of data handling and making visuals. So we're going to need the math library. I'm sure that surprises nobody in the room here. And the math library has a lot of the basic functions that you really need in there. It's got your trig functions, it's got logarithms, it's got pi to all the decimal places, it's got square roots and cube roots and all the stuff that we know and love from math. So what you would do is you would uh, declare this library in your workspace, and then you can call the various functions that are in there. Now, Python natively without this library doesn't actually know these functions. It can do arithmetic operations like multiplying and adding and stuff, but you need the math library to do any sort of function work. And if you're really clever and know a lot about Taylor series and interpolation and lookup tables and all that, I guess you could define your own math, but like, why would you? All right. NumPy is the one. This is the goat of math in Python. Uh, if I were smart, I would have had a goat pop up on the slides here. Maybe I'll edit it in post, but probably not. So NumPy, numerical Python, number manipulation in Python. And the thing about NumPy that is great is that it gives us a lot of the functionality that you might know from MATLAB. So things like manipulating vectors and matrices and arrays, handling different sorts of numerical variable types. NumPy is going to have a lot of functionality for that. And then it's also going to be able to do a lot of the different math operations and functional relationships that we need as well. As the slide says, all these things are very well documented online. I wouldn't spend hours reading the documentation myself, nor would I recommend anyone else to, but spending a few minutes skimming through it and just kind of noticing things, and importantly, looking stuff up when you need it. If you're like, oh, how do I do this in Python? Look it up, get in there, find what you need. Then we have SciPy. So this is for scientific computation, and it has a lot of the sort of signal processing and statistical and data handling, data manipulation functions that we need, as well as doing things like numerical differentiation, numerical integration, doing linear algebra, things like eigenvalue solvers. So these more advanced tools that we're going to need for handling data and for manipulating data sets and mapping them onto functions and doing curve fitting and so on is going to happen in SciPy. We love it. So math, NumPy, SciPy. That's it. So at this point, we're going to hop over to the browser and do a little bit of vibe coding so I can demonstrate what this looks like in practice. It is vibe coding time. Here we are in UMGPT. Now, you can use whichever large language model you want to. The advantages of UMGPT primarily are that it respects your privacy, to be honest. Uh, ChatGPT, Gemini, Claude, like all that business, they all work. They all have slightly different strengths and weaknesses, but all of the commercial LLMs out there fundamentally have two issues. One is that the way they're structured, they want to drive engagement. They want to keep you using them because attention and clicks is currency. So the some of the way that they structure the inputs and outputs are actually optimized for user retention rather than for strict functionality. Now, UMGPT is not perfect in that regard, but at least it's not actively trying to monetize you. And then the other thing is that speaking of monetization, UMGPT has really good privacy protections because of the academic license that we have for it. So if there are any concerns that you have in that regard, with respect to your own sort of privacy and um, the online world having access to all of your data, then UMGPT gives you some safeguards in that respect. That said, make your own decisions. You're an adult, do what you want. All right. So we're going to do some vibe coding here. I've just got 2 tabs open. This is not my real Chrome window. We're not going to talk about how many tabs that has open. Um, so I've got UMGBT open, and then I also have Google Collab open in the other tab. For most of my simple tasks, which is almost all of my coding tasks, I just run everything in Google Collab. It's simple, it works. And a big advantage of Google Collab is it already has all of the libraries installed, and you don't have to download or install or manage or run anything locally on your own machine in order for it to work. So it's very great for plug and play. Just hop in, put in your code, run it, and you're done. Now, for more sophisticated applications, you likely would want to download and run and install and configure your own setup on your machine, but that's not what we're doing here. We are just doing some vibe coding. So I am going to make a matrix calculator. That is not the most exciting task in the world, but like it's day 2 of class. We haven't exactly learned a lot yet. Technically, I haven't even taught you how to multiply matrices yet. I'm hoping you saw that in a previous course. So here's what's going to happen. I am going to um, tell UMGPT exactly what I want my script to do and how I want it to accomplish that. This is actually a really important factor to take into account is if I just tell it, write a Python script for multiplying matrices, it will absolutely come up with something and it might even work. It'll probably work to an extent, but it may not do exactly what I want. And especially thinking about user interface and user experience, it's unlikely to structure things the way I want them structured. So I'm going into quite a bit of detail to really specify step by step how the program operates. I also recommend this as an approach because, well, for 2 reasons. One is from a utilitarian point of view, when you tell it exactly how you want the code to work, then if issues do arise and you have to do any debugging, it's going to be a lot easier to get in there and figure out where the issues are because you have already worked out the structure. And then the other reason is more from a learning point of view, which is that if you take the time to think about what you want your code to accomplish and how you want it to accomplish that, that's really going to help you with understanding the problem that you're trying to solve. If we're doing a mathematical problem like solving a differential equation, I mean, there's lots of ways to solve differential equations. And even numerically, there's different methods for generating numerical solutions. So taking the time to be intentional and make sure, do I understand what this is for? Do I have a good level of conceptual comprehension about what this task is, how it can be accomplished, what the different components of my script are going to be and how they're going to interact with each other. Laying out that structure in your head is really going to help you with learning and understanding what's going on. So there you go. That's my speech. I have followed my own advice here, trying to be a good role model. So program asks the user to input the dimensions of matrix A and then the dimensions of matrix B. It checks if it is possible to multiply the matrices based on their sizes. Now, I have not tested this yet. This is a live, like real, no kidding, first try. We're going to see what happens here. I'm curious whether GPT would create code that does any sort of error checking if I did not explicitly instruct it to do so. It might, but it might not. So that's a good example of designing your own code and telling the machine exactly how to do it. I want to do this particular error checking step to prevent issues later. If anyone wants to give it just a very vague instruction like write a script to multiply matrices, I'd be curious to see how it implements it without this level of direction. Anyway, so we're doing this error check. Is the multiplication possible? And then if the multiplication is not possible, give an error message, go back to start. If multiplication is possible, have the user input the matrix elements and then do the multiplication. And I did specify using the NumPy library functions. This is also important to give this level of specificity, especially as we get into more advanced problems, because there are often different ways to implement calculations, and there are often multiple different libraries that have code or that have functions or routines built in for accomplishing different tasks. And specifying which one you want to use can make your code more efficient if you're using a library that is optimized for the purpose that you are working on. So there we go. So I've written up my instructions, natural language. Here's what I want to do, and go. Come on, UMGPT, you can do it. Oh man, there wasn't even time for me to sing elevator music. All right, so I'm looking at the code here, and it's like blah, 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 get matrix dimensions, do some stuff. I'm just skimming through this real quick. I truly have not done this before. I wanted to have the true vibe experience. I mean, I haven't done this exact task before, but yeah, we're going to get matrix dimensions, we're going to get matrix elements, and then our actual main body of the program should be where we run through and do our error checking, do the columns of A equal the rows of B. Great, that is the correct check to do to see if matrix multiplication is legal. And then we use NP, yes. So it is using NumPy as I required it to do. NP here is coming from the import NumPy as NP. So it's just doing a little shorthand thing so that if you're calling a bunch of functions from a given library, then you don't have to type so many letters in the code. All right, so we're using the NumPy dot function and multiplying matrices as we should. Great. Let me know if you'd like any enhancements or if you want this script tailored for an interface like Jupyter Notebook or as a function. Thanks. I do actually want an enhancement. I really want to get sassy with GPT, but I'm not gonna keep it direct. Um, Comments to the code. This is something I actually should have done in the first place. But when I'm writing code that I may not know exactly how it works, like I might not know some of the syntax details, or I might not be familiar with some of the implementation of different numerical methods, like different integration routines, for example. Add comments to the code, giving more verbose description of the functions and how they work so I can understand it better as a learner. Another really nice tip for prompting is giving this sort of role specific information. Like I would love to just get into how transformers work. We'll actually do a little bit of that later this semester after we do our linear algebra stuff. I do want to come back to be like, how does the magical answer box produce its magical answers? It's quite interesting. It's a great application of linear algebra. Um, but as it turns out, the way that we specify roles, I am taking the role of so and so, now do this task. That really helps contextualize the operations that it does so that you get more relevant and more useful results. Wow, look at all of these comments that have appeared in the code. I'm comparing it top and bottom. All right, this looks nice. And it's given me a lot of commentary on what the arguments and what the returns of each function are, and it's actually specified them out in language, which is great. So I'm actually real happy about this. So I am going to now grab my code, boop, and then we're going to pop over to Collab. I am just going to do a new notebook in my Google Drive. And this is where I stare awkwardly and hope it runs. Okay, great. Oh, interesting. It has a built-in generator now. That's cool. I'm sure it's powered by Gemini, which again is fine and works most of the time. All right. So here is my code. I just pasted it in, Control C, Control V, And now I hit run, and we'll see if it runs. Enter the number of rows for matrix A. This is very exciting. 2 rows by 3 columns, and then I'll have this be 2 rows by 2 columns, so it should break. These are not legal to multiply. Hey, it gave me an error message. Number of columns must equal. Okay, great. So I'm just going to do 2 by 2 matrix multiplication, which like I can literally do in my head at this point in my life. I don't need the computer for it, but we're just demonstrating, right? And notice it says separated by spaces. Okay, 1, 2, 4, 1, and then 3, -1, 0, 2. Just making up numbers. And now it's giving me the multiplication output. I'm actually going to check this in my head real quick now that I've made that bold argument. Yeah, okay. I think it works. I think we're good. Dope. All right, so I made a matrix multiplier. Like, not that that's a big accomplishment or anything, but the point is that, I produced this 100 or so line, whatever, 60, 70, I can't count. But, I produced this Python script in a couple minutes by thinking about what I wanted it to do, not getting bogged down in the details of the syntax of how to do it. So it really is a powerful tool. All right. That's really everything I wanted to say here. We're going to get plenty of practice with this over the course of the semester, but I just wanted to introduce the idea so that if you haven't seen this before, or if you didn't know that this was a possibility for how to use large language models, then now you know, and knowing is half the battle. All right. I will see you next time.